Hello everyone. The big question right now is most people are looking for the Pfizer vaccine. They say, well, we like to get the Pfizer or Moderna because their efficacy is 95% and Astra is 65%. So the media outlets, various media outlets, Vox and NBC, I heard, that they're saying, well, there's not much of a difference between 65 and 95. Don't go looking for Pfizer. Just get whatever vaccine that they give you. Now, is that really true? So that's the whole exercise that I'm planning to do here. So the question is 65 is same as 95? Oh, there's not much difference. So what are the logics that are being put forward? Well, number one, that they say that Pfizer was done when people were not much immune to the virus. Astra was done when people were more immune. So the number has to be lower because people are more immune. Because people were more exposed to the virus, so they're more immune, so they cannot reach 95, but they would reach 65. So that's good. And on the other hand, they say if Pfizer were to do the test later on, when the people were more immune, the numbers would also be similar to Astra. Because, people were more immune, so it's difficult to get the efficacy rates then as good as the ones that when the people were not that immune. And the other argument is that Astra testing was done in South Africa and they were exposed to different strains and etc. So anyway, so first question is how to calculate the efficacy. So I have this New York Times article. Basically they are coming up, they are just repeating the CDC method, and FDA has a different method, but the numbers are almost the same. CDC method is much easier, and they both give the similar kind of numbers, more approximate CDC method, but the FDA has very elaborate procedure. So anyway, how do they do it? And these are the real numbers. The Pfizer, they had 21,830 people placebo and 162 got infected. 21,830 vaccinated, 8 got infected. So there's a risk has gone down significantly here. So the risk here is placebo group is 0.74. 162 divided by 21,830. Vaccinated group 8 by this 0.04. So the risk was reduced by 0.7. 0.744 to 0.04. The risk was reduced by a number of 0.7. And then how to calculate the efficacy? Efficacy is calculated by the risk reduction. That will be 0.7 divided by the original risk, and that's how you got your 95. So let's look at the spreadsheet here. So I have the equation here: change in risk due to vaccination divided by the original risk. So the Pfizer, the same numbers I'm repeating here: 162, 21,830 number of people in the vaccinated group, and here I have an added column here. Now what would happen to the vaccinated group if the vaccine was not given to them? How many people would get sick? It would be 162, because the vaccinated group and the placebo group are identical. Identical means they pick certain amount of old people, certain amount of old people in the same, in both groups, certain amount of women, they are on the same, certain amount of men, certain amount of different ethnic groups. They're basically the same type of group. So if the placebo group, which did not get the vaccine got 162 people sick, and this group also should get, may not be exactly 162, but something similar. So, and once they were vaccinated, and their sick number was only 8. So the risk in placebo group is 0.74. That would be 162 divided by this, and risk in vaccinated group is 8 divided by 21,830. Change in risk is 0.7. Efficacy is 0.7. Change in risk divided by the original risk, and you get the 95. Now the Astra, I don't have the exact numbers, but I just assume the same amount of people and see how it comes up. 21,830 people. Now I assumed that the people now have developed immunity, because it was Astra was done later on. So people have exposed to the COVID and they have some immunity. So I would say that if you take 30% immunity, then then it will be 162 times 0.7. 162 times 0.7 is 113.4. That's how I got this number. And same number, because they have to use the same group of people, potential sick in vaccinated group, if the vaccine was not given, would be 113.4. Now, we know that the Astra number is 65, efficacy is 65. Now, to get the efficacy of 65, how many people have to get sick? 40. That's how I did. I ran the equation here. You could check yourself. And to get an efficacy of 65, you need to have 40 people sick. Risk in placebo group, 113 divided by 21,830. Risk in vaccinated group, 40 divided by 21,830. Change in risk, and change in risk divided by the original risk. So to get a 65% efficacy, you need to have 40 people sick, more than 8. Now if you put 8 here, just to show you, see, this jumps to 93. It won't jump to 95 because people have developed immunity, so these numbers have changed. So let's go back to 40, and you keep your 65 here. Efficacy is 65. Okay, so let's go through again. Pfizer, 21,830 people in the placebo, 162 got sick. 21,830 in the vaccinated group. 162 would have gotten sick if they were not given the vaccine, because the two groups are the same. But after given the vaccine, it will be 8. The Astra group, when people were much more immune, and then I brought down this number because now they're immune by 30%, so now it's 113.4. This is the potential sick in the vaccinated group if they were not given the vaccine. And this is the 40 that I got based on efficacy of 65. So these are the numbers. So now let's go through facts. Fact 1. When Astra test was done, people were more immune, because it was done 6 months or 4 whatever months later. Fact 2. Hence the number of sick after the vaccine should be less than 8 if Astra is as good as Pfizer. Okay. Now, Pfizer took a sicker group and brought the sick to 8. They took a sicker group of 21,830 and they brought that number to 8. And Astra took a much better, stronger group and they brought it down only to 40. Now, if Pfizer were to do the test later, and these people are much better immune, this number would be less than 8. Why? Because they took a sicker team and brought it down to 8. And if they have a healthier team, their number would be less than 8. Would be like 6. See, you get 95%, 94. So, so the Pfizer if Pfizer were to do the test, it's like if you're a coach and if you take a weaker team and win the cup, and if you get a better team, then why wouldn't you win the cup again? That kind of thing. But you know, it's not an exact example, but something like that. So Pfizer took a weaker team and brought it down to 8. And if they were given a stronger team, then they would be bringing that number less than 8. So that's the logic here. And fact 5. If Astra had done the test earlier, same time as Pfizer, their sick would be more than 40. Okay, let's look at that. Now, Astra had a better immune people, and they still ended up with 46. Now, if they had a sicker group, this number would be more than 40. Number would be like 50 or something. So it would be 69% efficacy. So to say that if Astra were to do the test earlier, their efficacy would be around 95. Doesn't hold water, because they took a better team of people, and they ended up with 40 sick. Now, if they had a much sicker group of people, less immune group of people, this number has to be more than 40 here. So that's what it says. So the Vox, this website, they say efficacy rate of Pfizer and Astra almost same, because Astra did the test when the immunity was better. I don't know how that could be ascertained, you know. And if Pfizer were to do the test same time as Astra, their numbers also would be around 65. If the Pfizer were to do around here, this number would be, they took a sicker team, sicker group of people, less immune group of people, and they took it to 8. And if they have a much more immune group of people, this number would be around 6. So it would be 95% almost. At least they should get 8. So it should be 93%. So that doesn't make sense. So overall, there's so this number was 40 before, right? Astra number is 40. So Astra took a better immune group of people, and they ended up with 40 sick. And if they had the less immune group of people, their number would be more than 40, let's say 50. So 8 and 50 is what we are comparing. So it's like 6-7 times less effective. Looks to me that way. Thanks a lot for listening.